Welcome to Study Loop.
A 1.2 kilogram piece of cheese is placed on a vertical spring of negligible mass and force constant K equals 1800 newtons per meter, and it's been compressed 15 centimeters. When the spring is released, how high does the cheese rise from this initial position? So I'm assuming by this initial position it means compressed, the compressed spring. Okay, so essentially the path forward in order to find how high it is released from its initial position is we need to write a conservation of energy between the point where we have a compressed spring and the point where it comes up to some height up here. Okay, so to do that, we're going to write the potential energy elastic is going to be some value, but then we're going to set that equal to the potential energy for gravity when it reaches the apex of its arc up to the top. Okay, so the expression for each of those is going to be 1/2 k x squared. Now x squared here is going to be the compressed length squared, and then we're going to set that equal to mgh, or that's the height from this initial position here. Okay, so we know what K is. X we're given to be 15 centimeters. Mass we know is 1.2 kilograms. G is a constant. So that just allows us to solve for H. Okay, so we have 1/2 times 1800 newtons per meter. And that's times 0.15 meters squared. Put in meters, substitute that in for centimeters. That's going to be equal to 1.2 kilograms times 9.81 meters per second squared times h. Okay, and so that should just be a straightforward calculation, and that should just leave us in units of meters. And what that gets us is height to be 1.72 meters from this initial position where it's compressed.